working with grid search takes a little bit of practice, I would admit. It takes a little bit of practice of making sure you understand what is going on and how it works. It could be a little more, it could be also confusing when we throw in pipelines into the mix. The examples we've seen before only work on, we're not working with pipelines, we're just working with just one machine learning model, one step, one estimator, not a pipeline that's going to encapsulate multiple estimators into one object. So I want to spend some time to gain some more practice with working with grid search, but specifically working with grid search and pipelines. It can be a little bit confusing. There's actually two ways you can go about working with grid search and pipelines. Let's go ahead and make sense of it. One thing I want to stress is that a pipeline is an estimator. A grid search object that you generate is itself an estimator. So let's go ahead and play around with some data. So we'll go ahead and import our famous California data set. Fetch California housing. Okay. And then I'm going to, from pre-processing, import grid search. So pre-processing import standard scalar. I'm going to use that. I'm also going to use grid search. And from sklearn.pipeline, import pipeline. And let's see anything else. Yeah, let's just I'm going to import a machine learning model to use. I'm going to use Ridge. Could be anything. Just going to use Ridge for illustrative purposes. And I'm going to say from sklearn, let's start practicing using train test split. I believe it's in model selection, import train test split. In fact, I can just tack that on there. Train test split. Go and run this. Okay. And then, as always, let's go ahead and get our data. Fetch California. Data, Y's, and targets. Let's do our train test split. %, test size, and set the random state to 0 for reproducibility. Okay, we got that up and going. All right, so let's say we want to construct a workflow. And let me open this up. So it's a two-step workflow where we're going to scale the data and then pass the scaled data to a ridge model. Scale, and then ridge. Okay, so let's use pipelines to encapsulate this right here. So let's see, pipeline, so scalar step, standard scalar. And the second step is my regressor and bridge. There you go. All right, train my pipeline, and let's see how well it works on test set. Okay, there you go. So I got 0.59 on the test set. Now, what if I wanted to tune the ridge's model's hyperparameters? I'm going to tune its hyperparameters. It has a key hyperparameter called alpha. That's what I want to tune. Pull out the documentation. All right, there is the hyperparameter I want to tune there, alpha. Okay. Now, remember, pipeline is an estimator. So what if we pass our pipeline into grid search? So I'm going to call an object called grid search. But before that, let's go ahead and see something with pipelines. There is a getParams method which will return all the parameters for the pipeline. And notice something here. Notice we see the name of the step where it comes into play. You can view pipeline is going to absorb all the parameters and hyperparameters for things like standard scalar and ridge. In order to differentiate those absorbed values, it's going to take that name we passed it. Take that name we passed it during creation and have it be a prefix. So copy, if it's the scalar one, it's scalar underscore copy. For regressor, it's regressor underscore copy. So we see here, this is the hyperparameter we want to tune, alpha. So it's not called alpha, it's called the name of the step, regressor underscore underscore alpha. And this matters because if I want to use grid search to tune this ridge model, the alpha value, I need to say regressor underscore underscore alpha. So now my param grid is going to be called regressor underscore underscore alpha. The values are the values I want to explore. I'm going to import NumPy. I don't think I did that. Just create a new cell here. Just import NumPy is NP. And it's customary when you tune alpha that you tune log spaces. Don't use a linear space, use a log space. So we'll do that right here. So log space, I'm going to say from 10 to the negative 3 to 10 to the 3, 20 spacings. Okay, let's go ahead and start doing the grid search. So we say grid search. I'm going to pass pipe, pass the param grid. I'm going to say 5-fold cross validation. Let's do run 2 in parallel. Let's say verbose equal to 1. And grid search dot fit x train y train. Let's run that cell. All right, it's undergoing fitting. And okay, that was pretty quick. So with our grid search to see what the best parameter was. So this is about 13, alpha value of 13 was the best one to use. Notice its name is regressor underscore alpha. You can also look at things like best score, which will return the best score, the best R squared value. Okay, so we did it that way. So that's one way to do it. Are there any downsides to this method? Any downside to the approach that I did right now? So what's happening is that even though, so here it takes around, it's very quick to train, so you don't see too much of a penalty. But notice when I call the fit method of our grid search object, it's going to fit. It's going to do k-fold cross validation, and it's going to fit, in this case, 20 candidates of my pipeline. So every time it's going to undergo the training process, what it's going to do is has to take the standard scalar, it's going to refit it, and then fit our regressor. Use a different value of alpha, it's going to refit standard scalar, and refit alpha, and refit ridge for a different alpha value. So by passing a pipeline to grid search, it has to refit all the estimators that are upstream. And that might be a problem because in this example here, I only want to tune the hyperparameter for that last step, for that ridge model. But doing the grid search, when I do grid search, it has to refit all the estimators upstream, all the estimators that belong to the pipeline. And that might be a little slow. In this case, standard scalar is very quick to train, but if I'd done a different estimator that is computation expensive, I have to do all these refittings that aren't necessary. There are several ways to go about this to fix this issue, and one of them is to make use of this feature called memory, which is a relatively new feature in scikit-learn. Let's go practice with it. So I can say from temp import mkdtemp. So this is a function for us to create a temporary directory, and then I'm also going to import another function called rmtree, which will remove a directory. So what we got to do first is we're going to create a cache directory. We do that using that mkdtemp function. And then when I create my pipeline, I'm going to pass this additional keyword argument. So I'm just copy paste it there. Alright, so in pipeline, I'm also going to specify a keyword argument called memory. And I set it equal to the cache directory. So this creates a temp directory. And what's going to happen is by setting this keyword memory into this temp directory, what it's going to do when I use something with grid search is that if grid search says, hey, I've already trained this estimator with this value, there's no need to retrain it. What I'll do is I'll cache it. What I've been doing is I'm caching those estimators. In other words, I've taken an estimator, I've trained it, I fit it, and I'm going to cache it to disk. I'm going to save it to disk, such that if later on I have to reuse that estimator with the exact same parameters, I'm not going to refit it. I'm going to load that cache file into memory. So hopefully this will speed up operations. You'll see a lot of speed up if these estimators are slow to train. In this situation, standard scaler is very quick to train, so you're not going to see that much of a performance gain by caching these estimators. So then once we create that pipeline, we'll just go ahead and go back to the original things we did. X train and Y train. And then we should run this. And there you go. And if you're wondering, one thing we can do here, we can go ahead and open up a terminal. Let's see if we can find that. Open up a terminal. Let's see if we can find that cache directory. Let's see. Okay, there you go. I believe this is a directory. Okay, there it is. This is where it's caching all those estimators here, if you're interested in where they're being cached. Now, a different approach we can undertake is, what if we have, in a step of our pipeline, a grid search object instead of bridge? We'll investigate that in future lectures.